How good is the model?
We are going to start with the first order trend surface, and we are going to do the leave one out cross validation. Remember that we created this script at the lesson 8 of the third geostatistic course. Then it's script number 43 is this one. Double click to open, and let's go to add the information here. That one is going to be the groundwater. This one is going to be X, Y. We are going to add the same parameters as before. 150,000. Lag distance 50,000. 15, sorry. Here is going to be the same as before. You know, the model is going to be fit automatically on the data. Then we can add values that are approximately. Then I'm going to add 3,000 here. The model here is going to be the spherical, the range as before, 100,000. Negative effect is going to be 1,000. Number of bins is going to be for the residuals associated with the cross validation. Okay, then it's going to be 10 bins, and title of the graph is going to be leave one out cross validation for spherical model for the first order trend surface. And that's it. We can run this script. And double click to open. A little bit less. If you want to know how to interpret well all this graph and all this data, my recommendation is just to watch the lesson 8 of the third geostatistic course. Over there you have a video tutorial about 1 hour and a half, and we explain everything really well, how you can make the interpretation of these graphs. Okay, I cannot take too much time here today because the video is already pretty long, and you have that video tutorial where everything is explained over there. Okay, then in this case what we are using is the leave one out cross validation. Here we have the bubble for the residuals, and what we want to look here in general is if there is any outlier that can make our model to be bad, right? Because if that happens, maybe we can consider to remove that value in order to have a better model. But as far as I can see, the bubble map, it's not bad. We have the values are pretty normal, right? And I'm going to say that is good, right? The residual values in general are good. Also, the QQ plot is related with the normality of the data associated with the residuals, and also we have a really good QQ plot. The histogram, as you can see, most of the values for the residuals are close to 0. That is really good, and also the distribution it's normal. Again, that's something good. And for the scatter plot, where we compare the predicted values with the observed values, what we have is that all the dots are pretty good, you know, they are pretty compacted, and we don't have dots that are out of the main cloud of points. And also the regression line, that is the black line, is pretty close to the ideal X scenario. That is going to be the red line. Then in general, we can say that this model is pretty good, okay? And we have here the values for some parameters, but the important one for us is going to be the root mean square error. That's the value that we are going to compare now with the second order trend surface to decide what model we are going to take for the final ordinary Kriging interpolation. And here again we have the parameters for the model. Now also I have to create the script for the second order trend surface. Then what I'm going to do is copy from the 20B the formula from here, edit the script. Then I'm going to copy the formula. copy, I'm going to close, and I'm going to paste in number 43. Is this one, edit the script. I'm going to change the formula over here. Formula, paste here, and that's it. And now I'm going to save this one with the same name, but I'm going to put B and second order. Save here, 43. This one, B and second order. Then save and close, and now we can look for that script. (43B), double click to open, and we are going to select now the parameters, but I'm going to pass the video faster. I added all the information, is the same as before. The only thing is changing here is the second order trend surface and the script, because the script is using the formula for the second order trend surface. Okay, then we can run this script. And here we have the root mean square error, that is 4831. For this one, for the first order, it was 4742. Then the first order, the root mean square error is smaller. Then for the Kriging interpolation, we are going to use the first order trend surface. Okay, but we can see also how looks like the graphs for the second order trend surface. Double click, and let's go to make this one bigger. And as you can see, both of them are pretty similar, right? This one is the first order and this one is the second order. Looks like the distribution for the residuals at the first order is a little bit better than the distribution for the second order, right? But the values are pretty similar. You know, we can use any of these two models because the difference for the root mean square error is very small, and any of these two, it is working well, okay? But as the simple model is the first order trend surface, we are going to take this one because we always want to take the simple one. We don't want to make the model complicated. It is not any necessity, right? Then we are going to take the simple one, and the simple one is the first order trend surface because we have also the value for the root mean square error that is less, is 4742. For the second order is 4831. It's just one unit, right? But we are going to use this one then. The next thing that we are going to do is check the isotropy and anisotropy of the data.